Right. Yeah. Hello, everybody. I'm Stan Kim, CEO at Stanime. Today's topic is strategy for developing treatment for rare intractable diseases using artificial intelligence. But I'll introduce our our AI platform called Stanime Ask for you today. That platform is for novel target discovery and prediction. But there is an intersection point with rare disease because rare disease intrinsically is a sort of biological malfunction. And STEM-S can predict the MOA and the target related things. So we can narrow down to the very genetic level of malfunction or patient level also. So I'd like to introduce our Stanime AI Ask platform first, and we can move to the rare disease topic. Right. Stanime's mission has three things. First one is value creation, and second one is first-in-class drug discovery, and the third one is continuous supply. First one and second one is very common in drug discovery area, but these two things are very difficult to achieve by artificial intelligence, not the traditional approaches. Third one is very native characteristic of artificial intelligence. Artificial intelligence can generate or predict continuous pipelines and their candidates. Right. So Stanime has two major AI platforms. First one is Stanime Ask, and second one is Stanime Best. We predict novel targets by Stanime Ask, and then the output of Stanime Ask is a novel target discovered by one for ourselves. Yeah. So there's a very novel target. And Stanime Best is for the generating or designing novel compounds. So Stanime Best to take the output of Stanime Ask and then generating novel molecules. So we call this process Magic Workflow AI. And we have very first-in-class assets from these platforms. And we move to our own pipelines. Yeah, these are the modules that each platform has. But we focus on first phase, the Stanime Ask target identification today. You know, there are so many human proteins, and we know the functions and structures of some of the proteins from the whole human proteins. And some of them, of the known proteins, are used for treatment that we call well-known targets. And there are so many unused targets for treatment, but druggable for the druggable proteins. We call this area very unknown or druggable proteins. So Stanime Ask can find that area druggable proteins from the unused for treatment. Stanime Ask overall map is there are several modules in the Stanime Ask platform. First one is called Pathfinder. It's actually a composition of two parts. First one is knowledge graph database. We assembled and integrated from the curated external databases and NLP technology for processing the literatures. And there are also, we have algorithms, deep learning based algorithms to infer the predicted target and then MOAs on that knowledge graph database. The other module called Wondera is omics database data set and algorithms and other modules we have. So, StandIMask, as I mentioned, has three parts. First one is graph database. That means this is a very massive database of nodes and edges. Those are all the sort of bio and medical entities, and then the links between the edges are their relationship, like inhibition or binding and so on, or expression. And there are algorithms, deep learning algorithms to infer or predict the relationship, hidden relationship between a disease and target. Some of them we can call the MOAs, and StandIMask has also interactive UI because we cannot solve every problems for drug target discovery because that side is very fundamental and natural science perspective we need. So we have to work together with researchers. So researchers can throw and give a query or hypothesis to the StandIMask platform, and they can narrow down to their expected evidence or hint, and finally, they can get to the truth. So so many nodes and relationships on the graph database, and we gather the nodes and edges from the literatures in real time and integrate that nodes and links into the existing graph database. These are our external databases we use to integrating our own graph database. And this is a very simple example of the algorithms. This algorithm train the patterns of extracted patterns of a target and a disease. That means training examples are their subgraph of a target, a disease. And the results. And Wondera use very mathematical, actually graphical mathematical approaches we use. So we can follow the protein-protein interactions on the graph database. The result. And as I mentioned, researchers can give a query, their hypothesis, and get down to the evidence or truth. We have 11 members now to develop StandIMask platform. 4 members are systems biologists and biochemists, the domain members, and the 4 are AI scientists developing the new algorithms of deep learning derived inference, knowledge graph algorithms, and so on, NLP algorithms. And AI engineer 3, back-end, front-end. StandIM has 25 members of AI members inside, so we work together to develop the STEM-esque platform, and we have 10 members of pipeline leaders. So we discuss and drive novel targets together in a domain side and algorithm side. We published the results at the RECOM 2020 last year. We did a comparison with JSK's result to the ability of predicting novel target, the hit ratio. And yeah, STEM-esque platform is just not just anyway, in silico and artificial intelligence predictions. That means just predictions. So we have to move to the validation, wet lab validation with predicted candidates. So we are doing then that validation on these several various diseases, fibrotic diseases, and prostate cancer, and then Parkinson's disease and COVID-19. So one of the fibrotic disease, we got the phase of in vivo, in front of in vivo, and in vitro validation was passed. So we expect to get our own novel target soon, in a few months. Yeah, there are behind the story. We predicted 20 target in silico target candidate, and the partner pick up 4 candidates from the 20, and one was revealed that already published in the earlier. So we removed one of them, and 3 are selected, and we got a very positive result. All of the 3 candidates. And there are our partners, Iowa Women's University and SK Chemicals, Miller Institute, University Cambridge, and SK Kids CNC for the novel target discovery, not the compound discovery. So we do a role of prediction, and collaborator partner has a role of experimental validation. Yeah, when we work together, we have this collaboration scheme. And yeah, Stenheim, yeah, I'm scared with the size of the members now. We have over 60 members, and we have 3 members in the US and 1 member in the UK. So in the UK, we work with the Cambridge University, and then also in the US, we have a plan to work together with companies there. And we started in 2015, and from the fund of from the Kakao Ventures, and 2019 SK Holdings, and recently we finished our pre-IPO and from the Intervest and SKS, and very recently, a few days ago, we got fund from the Strategic Investment Fund from the SK Chemicals. Yeah, thank you so much.